In this video, we're going to discuss vMotion. Now, vMotion is an excellent feature that allows us to take a virtual machine and while it's running, move it from one host to another. In previous versions of VMware, this required us to have the virtual machine on shared storage, which in my environment, I do have shared storage, but it's actually no longer a requirement. If my virtual machine is on shared storage, then it's going to be much faster to transfer the machine because we really only need to transfer the memory state from the first host onto the new host. Now, that memory state is going to be different depending on the type of processor we have in the physical machines. And although we use virtualized hardware, the processors are not really fully virtualized, so some of the functionality of the physical processors is visible to the virtual machines themselves, and the memory layout will be influenced by that. So we need to be able to take the currently running state of the virtual machine and move it to the other host. This requires us really to have the same type of processor architecture. It's all going to be x64 systems anyway. We don't have support for any other instruction sets, but it has to be all Intel or all AMD. And it's much easier to go from an older version of a CPU to a newer version because we can be sure that all the capabilities and functionality of the CPU will still be present. When we're using DRS, the Distributed Resource Scheduler, we can set our cluster to run in enhanced vMotion compatibility mode, where we'll actually set the configuration of each of the CPUs in the cluster to be the same as the lowest common denominator CPU in the cluster. And that way we can more easily move virtual machines back and forth without having to worry about whether we're going from a new generation to an old generation. When we start dynamically adapting the workload in the cluster using DRS, then it's going to be very important that we're able to do that consistently and properly. So assuming that we want to be able to perform vMotion, and there's lots of good reasons to do that, primarily now we're going to be able to move a virtual workload from one host to another. It's going to make it much easier to do maintenance of those hosts. And in fact, when we use the DRS clustering, then when we place a host into maintenance mode, we can have its workload vacated automatically. We'll take a look at DRS in a later video. In this case, we're going to look directly at performing vMotion manually. If I have the matching CPU architecture requirements, then really what we need is a network interface that's marked as being capable of being used for vMotion. So we can see that I have one vSwitch configured for my virtual machine traffic, another vSwitch with NICs associated with it that I'm using for my NFS storage. Then I also created an additional vSwitch which has two NICs associated with it and is using a VM kernel port which is marked as being used for vMotion. I've named it VM kernel vMotion, but that's just a name. So if I go into the properties and then click on my VM kernel vMotion VM kernel interface and click edit, we can see that there's an option for vMotion and it's enabled. Now, as for IP settings, this is really just a private VLAN between the two machines, so I really don't need to provide any working TCP/IP configuration that's going to allow us to route traffic in or out of this particular VLAN. All we need to be able to do here is transfer the memory pages between the hosts. Or if there was no shared storage, we would also need to transfer the disk pages, and that's going to take much longer to perform a vMotion anyway. So if we can reasonably assume that our other host is set up the same way, and in this case I did, then we should be able to go ahead and perform a vMotion. So if I right click on one of my virtual machines, we'll see there's an option to migrate, and I can choose either to change the host or to change the data store. For more information about doing a storage vMotion where we change the data store, take a look at the storage vMotion videos. So in this case, I'm just going to select change host and click next, and then select the other host where this virtual machine is not currently running. Now, if there are resource pools on the other host, we're going to need to select which resource pool to put the virtual machines in. Now, we have the ability to do this either at high priority or at standard priority. If we're doing lots of simultaneous vMotions, then network speed is going to be a factor. The amount of activity going on inside the virtual machines is going to be a factor. And if we're doing a lot of virtual machines all at once, we can say some of them will be done at high priority and others at standard priority. And I'll just click next and then finish. And we can see down in the task pane that our migration has started. It really doesn't take very long at all. So performing a vMotion is really pretty straightforward. Really, the only thing that we need to worry about is how this is actually going to happen and how it's going to impact what's running inside of the virtual machine. It really is not completely transparent to the guests. what ends up happening is that we'll start syncing memory between the two hosts, and once a certain balance is reached, we're going to transfer control of the virtual machine itself from the current host onto the new host. Now, depending on exactly what the memory state is, there may be cases where we've already copied some memory, but then it had to be modified after it was copied, or where we've transferred control and there were still some hot memory pages on the other host, and vice versa. So in addition to using these vMotion network interfaces for transferring the memory pages, that can actually be used as a live memory bus, much like we can reach onto the disk to get memory pages out of the swap file. One or the other host can actually reach across these network interfaces and retrieve pages that have gone dirty again after they've been modified, and make sure that this process can continue and that it can be backed out of. If for whatever reason the vMotion can't happen after it's started, then the system may back out of it automatically, and we're going to make sure that that system stays in a consistent state. So really what ends up happening is we're going to have a quick loss of network connectivity, and then it's going to come back on really a different switch port on the physical switches, and also on the virtual switches. The impact should really be minimal. Any protocols that are using the transmission control protocol, we have error correction mechanisms there. It will detect that there's been packets missed and will resend them. This is handled differently than the way network failover happens when we're using multiple switches and we're preferably using ether channel and NIC teaming from our switch to our hosts. It's important to test what's supported and what your vendor recommends doing and whether or not this is something viable for your application. We may also have to create dependencies and relationships between virtual machines to keep them together for whatever reason. So take a look at the DRS videos, take a look at the storage vMotion videos, and you'll get more information about that. And also take a look at the resource pools videos, which really in a lot of ways, a DRS cluster is sort of a super resource pool. All those things come together to automate this if you have an enterprise edition of the product anyway.